Hello guys, this is our lesson 13.2. We're going to be doing two really important things here. We're going to be multiplying polynomials. You've done a little bit of that before. We're going to do more. And some of that will be new. And then we're also going to be factoring using the greatest common factor, which you haven't really done that before. You have used greatest common factor back in elementary school, but we're going to be doing some different things with it. Okay, so I want you to do the warm-up. If you haven't already done the warm-up, pause the video, give about 4 or 5 minutes, and then you can do the warm-up, and then we'll get started. Okay, going over the warm-up, you look for like terms here. 2a squared and 3a squared is 5a squared. Remember that when you add, you do not do anything to the exponents. Like cookie and cookie, you have 2 cookies. You don't have 2 cookie squares. Okay, number 2, looking for like terms. I've got negative 3x squared and negative 2x squared. That's negative 5x squared plus 4. Like terms. Remember, you multiply, you don't need like terms. You add and subtract, you do need like terms. Okay, somehow it looks like I forgot. Oh, I know what I did. Scoot it down, there we go. Okay, 3 and 4. So we're going to distribute. So distributive property, negative 2x, and negative 2 times negative 4 is plus 8. And that's your answer. Okay, number 4, 3x times x squared is 3x to the 3rd power. 3x times negative 1 is negative 3x. So those are your answers. You can't combine like terms. There are no like terms. You're not going to be able to do anything else. That's it. Okay, so next one, number 5. On this one, you've got 2x, and then this negative 3 is what's being distributed. So negative 3x minus 6. So negative x minus 6, and that's your answer. You could write negative 1x, please don't. Just write negative x minus 6. Okay, number 6, 5x times negative 2x, that's negative 10x to the 2nd power. 5x times 4x, 20x squared. Okay, so our first thing that we're going to be doing is talking about multiplying polynomials, which kind of that's what we're doing, but we need some vocabulary first. So some of these things we've already learned. So a term, remember that each of these things would be considered one term. Okay, so it doesn't matter how many letters are there, it's either a number, a variable, or a number and a variable multiplied together. That makes one term. So this is an example of 5 terms right here. Okay, coefficient, you know what that means. It's the number part of a variable or number part of a term. So in negative 4a, negative 4 is the coefficient. In 6x squared y to the 3rd, 6 is the coefficient. Okay, like terms, we were just barely saying that. Like terms have the same variable and powers. In other words, the variable parts match exactly. Okay, what does exactly mean? It means nothing is different as far as the variable parts. The coefficients can be different, but not the variable parts. So if you look at this example, 4a squared b and negative 8a squared b are like terms because the variable parts match. Negative 1/2 x squared y and 15x squared y, those are like terms because the variable parts match the x squared y, x squared y. In contrast, this example right here, not like terms. A to the 3rd b squared and a to the 2nd b to the 3rd are not like terms. The variable parts do not match exactly. It doesn't matter that the coefficients are the same. What matters is that the variable parts are the same. So if I said add these two, you can't. If I said add this, can't do anything. That's it. Okay, the next thing we're going to be talking about is some new stuff. So the term monomial, okay, the prefix mono means one. So it's an expression of a single term. It has constants or variables or both that are being multiplied together. So these examples might look familiar. We were talking about those when they were terms. So a single term is a monomial. So those are 5 monomial examples. Okay, a binomial. The prefix bi means 2, like a bicycle has 2 wheels. So a binomial is an expression sum, and you can put or difference, because if you're adding or subtracting is just adding but with a negative sign. So the sum or difference of 2 monomials. So for example, 6 plus x squared, we've got a monomial plus a monomial. Negative 5 and 3ab, I'm subtracting them, so I'm subtracting two monomials. So these are binomials. I can't do anything to simplify them. If I had like x plus 2x, that's actually not a binomial, it's a monomial because it's equal to 3x. Okay, so if you can simplify it, you have to simplify it before you can name it. So those are examples of binomials. Okay, the next one, trinomial. So as you might guess, tri means three, like a tricycle has three wheels. A trinomial is an expression of the sum or difference of three monomials. So for example, 2 plus x minus 3x squared. So I've got 1, 2, 3, and they're all separated by a plus or a minus sign. So that's a trinomial. Here's one term, two terms, three terms. That's a trinomial. Now, yeah, we can have expressions that have 4 terms or 5 terms or 10 terms, and so we don't have all these prefixes because that would be really hard to remember. So we have this generic term called polynomial. So poly means many, and you can use that for an expression of one or more monomials. So you can have a monomial all the way up to, you know, as many terms as you want to have, and it can be called a polynomial. So it's just a generic term. So all of the examples when we talked about monomials, binomials, trinomials, those are all polynomials. And then you could have, of course, you know, something like, you know, x to the 5th plus y to the 3rd minus 3xy plus 2z minus 10, and that would, you know, be a polynomial. So polynomial is just what we talk about in general. Okay, next we're going to talk about the degree of a polynomial. So when we talk about the degree of a polynomial, we're talking about like kind of its importance, or you know what the exponents are. And so what it is it's a sum of the exponents. So we're going to take the exponents in a single term and add them together, and whichever one has the largest sum, that tells us the degree of the polynomial. The coefficient does not matter when we do this. So examples. If I have 4a minus 3ab plus 5b, I've got 1, 2, 3 terms. This is a trinomial, by the way. It doesn't ask you for that, but just you might want to write that down. So it's a trinomial. Now, as far as what the degrees are, let's look at this. This first term has a degree 1. This has a degree 2 because it's a to the first, b to the first, and 1 plus 1 is 2. This is 5b to the first, so I've got either a 1, a 2, or a 1. Since 2 is the largest, it's degree 2. Okay, the next one, 6 plus x squared. I've got 2 terms. It's a binomial. And so I've got this. This is degree 0 because there's no variables. So like x to the 0 is just 1, so 6 times 1 is 6. So that's degree 0, and then this one is degree 2. So 2 is bigger than 0, therefore it's degree 2. The next one, 5xy squared, that's just a monomial, but that doesn't have anything to do with the degree. Look at your variables, x to the first, y to the second. Since 1 plus 2 is 3, that's the degree. The next one is also a monomial. I've got x to the third, y to the fourth, z to the second. Since 3 plus 4 plus 2 is 9, that's a degree 9 monomial. And then the last one is degree 1 because 2x to the first power, that's just the only degree. So there you go. Okay, standard form. We have ways to write things so that we all do the same thing, so that we're not all writing the same thing 6 different ways. So there's a standard for how we write things. So the standard form of a polynomial, the variables are going to be arranged in alphabetical order, so A to Z, and the terms are arranged in descending order according to degrees. So for example, if we have 2 plus x minus 3x squared, I've got 3 terms, 1, 2, 3. They're all the same variable, x, so I don't have to worry about the alphabetical order part, but if I look at the degrees, this is degree 0, this is degree 1, and this is degree 2. Since 2 is the biggest, it has to be written first, and then degree 1, and then degree 0. This would be our standard form. Look at the next one. I've got 2 variables, m and p. So since m comes first in the alphabet, the m's will have to come first. Well, which one comes first? M to the fourth is going to come before m to the second. And then p to the fourth will come before p to the second. So this is our standard form. Now remember what I said, that if you can simplify a polynomial, you need to do it before you tell me it's a monomial or a binomial or trinomial. So if you have x plus 2x minus 10 plus 4x, and you tell me that, you know, that's a polynomial because you don't know what the, you know, quadrinomial or whatever, that would be wrong because you can say x plus 2x, that's 3x, plus 4x, that's 7x minus 10. This is actually just a binomial. So if you can simplify it, you have to do that before you can name it. Okay, so the next examples, we're going to name the polynomial, whether it's a monomial, binomial, or trinomial, and tell me the degree of the polynomial. So pause the video, do 7 through 10, and then we'll see if you're right. Okay, number 7, this is a monomial, and it is degree 2. Number 8 is a binomial, and this one's degree 2, degree 1, so 2 it is. Number 9, this is a trinomial. By the way, it's not in standard form. If we were going to write that in standard form, we would do 4x squared minus 2x plus 5. Okay, so it's degree 2 because that's the highest degree. Number 10, be careful with that. You notice that that's not a plus sign, it's not a minus sign. So therefore, we have to take care of that. So 2x times 4x squared is 8x to the third power. That's a monomial. So if you said binomial, you maybe don't understand what that means. You have to have a plus or minus sign in between the terms to make it a binomial. And this is degree 3. Okay, number 11. The parentheses are around there, but there's nothing to multiply, so the parentheses don't really mean anything in this problem. So this is a binomial. I can't combine any terms or anything. I've got degree 6 versus degree 2, so it's degree 6. And then the last one is a trinomial. I cannot add any of those things together because none of my variable parts match exactly. xy does not match x. This is degree 2, and this is degree 1, and this is degree 0. So it's degree 2. Okay, so the next part is we're going to simplify by combining like terms, and we're going to write it in standard form. So that's kind of the key part here. Sorry about my overflow. I was trying to fit the screen. So anyway, you're going to take each one of these and write them in standard form. So number 13, this one, we look at our variables. I've got 3x squared minus x squared. I can do something with that. That's 2x squared. And then plus 4x plus 2. That's my standard form. Highest degree down to lowest degree. Number 14, x squared is the highest degree of my x's there, so I'm going to write that as 5x squared. And then I've got negative 8x and 10x, so negative 8 plus 10 is 2x. And then minus 4. And then number 15, I've got x squared, so I've got 3x squared and 5x squared. And then I've got 2x minus 4x, and then plus 6. So those are written in standard form. Okay, now all of this stuff is preliminary to being able to multiply our polynomials. You've already done some multiplying with polynomials before when you first learned about the distributive property. We're going to do a lot more than that. So we will be using the distributive property a lot, and we're also going to be using the properties of exponents, like when you have x to the third times x to the second, it's x to the fifth. So on any of these, if you're not sure about what to do with the exponents, write it out. So you could write out x to the third times x to the second and see that it's x to the fifth. But if you're not sure, you need to write it out, because if you get one single exponent wrong, then your whole thing is wrong. And down the road, when we use all of this stuff to do other things, that's going to have consequences. Okay, so 16, this is just the distributive property. The difference here is we have to worry about the exponents a little bit more than you've had to in the past. So we're going to do 3x times x. That'll be 3x to the second power. 3x times 4, 12x. I can't combine any like terms. There are no like terms. It's in standard form, so I'm done. Okay, number 17, negative 2x to the third times 4x. That's negative 8. X to the fourth. Negative 2x to the third times 5 is negative 10. X to the third. Is it in standard form? Yes. I can't combine anything. Highest degree to lowest degree. Okay, number 18. M. This is a monomial. Oh, sorry, I was thinking it was a different one. Sorry, m times 6m is 6m to the second. And m times m to the third is m to the fourth. Is that in standard form? No, it's not, because m to the fourth needs to come first. So yes, you do need to write it in standard form. If you don't, then you'll lose. Okay, so that's going to be what standard form looks like. Okay, number 19, this is the one I was thinking of. This is a monomial times a trinomial. So it doesn't really make any difference. You're just going to have more terms. So watch your signs, watch your exponents. Negative 2 times 1 is negative 2. A times a to the third is a to the fourth times b. Negative 2ab times 4ab squared is negative 8. A to the second, b to the third. Negative 2ab times 6 is negative 12ab. Now we need to check and make sure we're in standard form. So AB is in everyone, so that's already in alphabetical order. You've got to check the degree. This is degree 5, this is degree 5, so which one comes first? Now you look at the A's, 4 versus 2. So that is in correct standard form. And so that's the answer. All right, let's go to the next ones. Now we're going to do, this is new, so this isn't just a distributive property like you've done it before. We're going to multiply two binomials. This is something that we're going to be doing a lot of this year, next year, and years to come. So we're going to have a binomial times a binomial. What we do with that is we just use the distributive property again and again. Okay, so we're going to distribute everything. So with number 20, you're going to start with the first term right there, a, and you're going to distribute, multiply by a, and then you're going to do a times 5. Okay, now you've used up that one, so now you're going to go to the second term, and now you're going to do 3 times a and 3 times 5. So that's a squared plus 8a plus 15. You can't combine like terms. There are no like terms now. You've taken care of all of it. That's your answer. So you're looking for the product of these two binomials. So let's pause, and you try 21 and 22. 23 is going to be different, and that's a special case, so just hold on for that one, and I'll show you. It's not as easy as you may think it is. So 21, 22, pause for a minute, and then we'll see if you're right. Okay, 21, x times 2x, x times 2, negative 3 times 2x, and negative 3 times 2. Combine your like terms. Now the way we've got this set up is most of the time your like terms for these problems are going to be in the middle. That's not going to be the case all the time, but the way that we've set up the problems, that's going to happen most often. So that's your answer. Okay, 22, you're going to do x times x, x times 2, negative 1 times x, and negative 1 times 2. Combine your like terms. And there you go. All right, now with 23, this one is, it's got a special name. It's called quantity squared. So maybe you might want to jot that down somewhere because I'll say that a lot. Quantity squared. When you see quantity squared, it means that we've got this quantity in parentheses and we're going to square that. And I see this mistake a lot where people will think, oh, that's an easy one. I just square this and I'm all done. And they're wrong. It doesn't work like that. So you need to take what this is and you need to write what it means. It means this. And if you don't write it out like that, I'm going to laugh at you when you get the wrong answer. Okay, so we're going to have x minus 5 times x minus 5. So x times x is x to the second power. X times negative 5, negative 5 times x, and negative 5 times negative 5. So you still have to watch your signs really carefully. Look at your like terms. I've got two like terms there in the middle, negative 5x and negative 5x. So you're going to have x squared minus 10x plus 25. Okay, that's your answer. If what a lot of people do is they look at the problem and they think, oh, I'm just going to do x squared and 5 squared, and they get the x squared and the 25 squared, but that's like having the Oreo without the middle. You can't have that. That's not the same thing. Okay, so that's going to be your answer. All right, let's go ahead and have you guys try 24 and 25. Pause the video. Okay, 24, 2x times 2x, 2x times negative 3, watch your signs, 3 times 2x, and 3 times negative 3. Notice this time that our terms in the middle, negative 6x plus 6x, they cancel out. So I'm left with 4x squared minus 9. This is a special situation, and we'll talk more about that in later lessons. But if you start to recognize the pattern that's happening there, that's really helpful later on. Okay, 25. 5x times negative 2x, 5x times 1, positive 8x, and negative 4. Combine your like terms. Also, the way that we're doing most of these, you're almost always going to have them be in standard form if you do everything in the right order anyway. And so you don't have to worry about that so much. Just give it a once over and just make sure it's in standard form. It shouldn't be that big of a deal. Okay, I'm going to stop this video. I'm going to start a new one because I'm limited on time, and then we'll get on to the rest of the lesson.